Hello guys, this is Paul McWhorter from TopTechBoy.com, and we're here today with lesson number 18 in our incredible new tutorial series where you're going to learn Python or you're going to die trying. What I'm going to need you to do is pour yourself a nice strong cup of black coffee. That is straight up black coffee, no sugar, no sweeteners, none needed. You guys watching this channel, you're jet fighter aircraft. This is your jet fuel. Go get you some. Okay, I'm also going to need you to get out your most excellent Visual Studio Code. And while you're firing up Visual Studio Code, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your encouragement and your support that keeps this great content coming. You guys that are not helping out yet, look in the description down below. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and let's talk about what we are going to learn today. What we are going to learn is we are going to learn about Python methods and Python classes. And this is where kind of like the big boy programming starts. And if you've ever looked at somebody's Python code who really knows what they're doing, it's completely confusing and it's like a foreign language, like you don't even know anything about Python when you look at it. And it's talking about classes and it's talking about selfs and inits and self.this, self.that, and it makes absolutely no sense at all. And that is because they are using classes and methods. It is called object-oriented computing. And what I'm going to show you today is how to do object-oriented computing. And that is going to be the use of methods and the use of classes. And once you see it, it really makes a lot of sense. Once someone shows it to you kind of step by step, it's really, really very logical and very straightforward and very easy to do. So without further ado, let's jump over to our most excellent Visual Studio Code and let's come over here. We're working in Python files. I'm going to come over, I'm going to add a file, and this is going to be class methods, classes and methods.py. The .py is kind of important, and boom, we've got ourselves a fresh new Python program just waiting to be written. All right. So now we could have a function that we called area, right? Last week we learned about functions. We could have a function called area, and you could pass it a length and you could pass it a width, and it would return to you an area. And so if you had 10 different rectangles, you could call it 10 different times. But then you're going to start getting kind of confused, because what if you really wanted to keep track of 10 different rectangles? You need a better way. Okay, and that better way is to be able to create an object, and that object would be a rectangle. And then I could create rectangle 1, or I could create rectangle 2, and you do that with classes. A class lets you create an object. So I could have a class. What type of class? A rectangle class, and that rectangle class would allow me to create rectangle objects, and I could work with those different objects independently through that Python class. Okay. Now, this is the neat thing about a class. It keeps track of data and it keeps track of functions. So let's say if we were talking about a rectangle, and rect1 might have a width of 1 and it might have a width of 1 and a length of 2. That is data that is going to be associated with that rectangle. So I create that rectangle, and then it keeps track of those parameters, the data. What's its length? What's its width? Oh, now I want to do a calculation. I could do the function inside that class of, let's say, calculating the area. So it has data, which would be like the length and the width of that rectangle, and it has functions like, oh, I might want to calculate the area, I might want to calculate the perimeter, I might want to calculate the diagonal, different things like that. So a class allows you to create objects, and those objects then you can keep track of specific parameters, and you can keep track like data, and then you can keep track of functions. So that's at a high level, and as you watch me do it, it is going to make more and more sense. So I am going to create a class, okay, a class, and that class is going to be called rectangle. And so I'm going to create a class, and then I'm going to create the class rectangle. And when you create the class, you don't pass class any parameters. It's just, this is my class. The class is called rectangle. Now, if I wanted to create a rectangle, if I wanted to create a rectangle object, I could say my rect1, and that's equal to rectangle. Now, Python knows that my rect1 is a rectangle. Now, it doesn't make much sense yet because I haven't really put any constructs in here, but I'm just saying I'm creating the object. What is the object? My rect1. My rect1 is a rectangle. And then how does it kind of get defined? It gets defined in what goes on in here. Hope that makes sense. Okay. I could then create a different rectangle. My rect2, that's a new object, and that would also be created by just calling rectangle. Well, now when you call rectangle, you have to set up the rectangle. Okay, you have to set up the rectangle. And so every class needs to have a function in it to set things up. Now, this is very important. We learned about functions last week, right? How do you define a function? DEF. You notice that this DEF is inside of class. This DEF is inside of class because it is indented. Well, when you're just out in Python making functions with DEF, they're called functions. But when you create a function inside of a class, it is called a method. It's just exactly like a function, but when you do a function inside of a class, you call the function a method. But we're going to define now our method, and it is the init method. Every class needs an init, and that sort of sets the object up when you create it. And you do that with underscore, underscore, init, underscore, underscore. Okay, so it's def define, and then a space, and then we're going to have this be the init method, and then we put the parameters in here. Well, we have to pass it self. Now, what is self? Well, if I create the object my rect1 by calling rectangle, it comes up to rectangle, and what is it? What's its name? It's my rect1. So you're passing down into this init function, this init method, self, and self is my rect2. Now, if I call rectangle again, I'm creating a totally separate object. That totally separate object is called my rect2. And so when I call rectangle with my rect2 and I come into this init method, and this init method is called, every time you create an object, it just runs the init method. That time self is going to be what? My rect2. So you're kind of telling init what your name is. Who are you? You are my rect1 or you are my rect2. Okay. Now, what are some, like we said that a class will keep track of data and it will keep track of functions or methods. What is some data that you might want to know about a rectangle? Well, you might want to know what color it is, so we would want C for color. You might want to know what its length is, so we'll pass L for length. And you might want to know what its width is, so we'll pass W for width. And so besides self, it needs to know what the color is, what the length is, and what the width is. All right. Now, again, we don't catch the parameters up here. What we do is we pass them here. And so what do I need to pass? I need to pass color, and I need to pass length, and I need to pass width. All right. So now I am going to create an object. That object is my rect1. That object is created with rectangle. It comes up here to rectangle. What does it do? When you create the object, it runs the init method. The init method receives the name of the object. So rectangle passes it, my rect1. So self becomes my rect1, and then here color goes to C, length goes to L, and width goes to W. So you pass the parameters not to rectangle, but you pass them into this init. Okay, the parameters go into this init, and just remember that self becomes its own name. Now, you want this class to keep track of these parameters, because when I come and do my rect2, I don't want it to forget what my rect1 was. So I want to keep track of the data. So I need to put these into variables. So really what I would want to do is something like my rect1 dot c is dot color. That's a variable, so like the color, my rect1.color, we would want that to be equal to C, the thing we passed it. Right, now what would be the problem with doing this? Then the name would always be my rect1, and then if I'm working with my rect2, it's hardwired to my rect1. So we want this to be my rect1 when we call my rect1. We want it to be my rect2 when we call my rect2. So instead of my rect1, my rect2, what should we put here? What should we put here? Self. Okay. So when I create my rect1 and it calls rectangle, rectangle runs the initialization method and it passes itself. In that case, it's my rect1. So saying self.color is C, that would be saying self.color is equal to, or that would be my rect1 is equal to C. Now, I think this would be clearer if I actually put numbers in here. So, or actual, I'm going to put in here red, and then I'm going to put in a length of 2 and a width of 1. So I create an object. That object is my rect1, and it is a rectangle. That hops up here to rectangle. When the object is created, it runs the init method. Init receives my rect1, and then what it does is it sets my rect1, which is self.color, to C. The C comes from here. So we pass 2 to C, and C goes into self.color. And so let's just do that simple thing, and then let's just say print self.color like that. Okay, because I've run this my rect1, it should know it. No, I don't want to say self. Now down here, I'm going to say my rect1, because here, when I'm down here in the code, I don't care about all this self stuff. What I care is I created a rectangle, my rect1, and now I want to know what color is my rect1. So let's run that thing, and boom, what does it print out? It prints out red. So I create an object, my rect1, by calling rectangle. Rectangle calls the init function. It passes itself, which is my rect1, and then CLW, and then it says self.color is equal to C, which was red, and then when I come down here, my rect1.color will be red. Now let's make another rectangle. My rect2 is going to be blue, okay, and then that's going to be comma, let's say 4, 2, 4 long and 2 wide. And then let me come here and copy this. All right, so what I want to show you is I create my rect1, I create my rect2, and then I'm going to print my rect1 color and then my rect2 color. Okay, so it prints red and blue. Do you see the power of this? When I create my rect2, it still remembers everything about my rect1. When I do my rect2, it doesn't mess up my rect1. So this self construct is a way that you can keep track of lots of different rectangles. So what else am I going to want to do? I want to keep track of self.length is equal to L, and then self.width is equal to W, and I hope that is an L. Man, it is a very dangerous thing, the difference between an L and a 1. Okay, that is indeed an L. All right, so now why would you not just say color equals C, length equal L, width equal W? Because then it couldn't keep track of them when you call the other object. And so when I do self dot, I can keep track of rect1 and I can keep track of rect2, if that makes sense. Okay. We could also say print my rect1 length equal, and that would be comma, what? My rect1 dot length, all right? And remember, it's this self dot length. It's not CLW, it's self dot length. Okay, my rect dot length. And then I can get this and copy it. And then I can make my rect2 length is equal to my rect2 dot length. And let's run this. And boom, we have red, and then my rect1 length is 2, and then we have blue, my rect2 length is 4. So you see, this is an ingenious construct where now this object, my rect1, it keeps track of all of its parameters, and you can go about doing your business and creating other rectangles without losing your old friend, my rect1. Now what you could imagine here is you could do everything inside of the init. I could do like a self.area is equal to self.length times self.width. But the problem is, for some rectangles, you might not care about the area. You might not care about that. So you don't want to start doing functions in here in your init. You only want to, or methods in that init, or calculations in that init. You want to create other methods for the things that you might want to calculate. And then you don't put them inside the init, you put them inside the class. And so I'm going to come over here and say what's something we might want. We might want the area. And all we have to pass it is self, like, so it will know that you're talking about my rect1 dot area. Okay, so you have to pass it self so it knows who it is. And then so what would that be? Well, I've already told the class what self color, self length, and self width is, and that's done the very first thing. So at this point, it knows self color, self length, and self width, and so I could just say self dot area is equal to self dot length times self dot width. All right, now this is something you don't want to, yeah, I'm not even going to show you because it's a bad way to do it. So what you want to do is, now that you know self dot area, you want to return self dot area. Okay, so now I've said print my rect dot color. That was just a straight out variable because it was defined here, self.color. All right. I've got my rect.length because it was right here, self.length. This defined this defined area, it has not been called. So what you got to do is you've got to call it. Well, how would you call it? You could do this. You could say print, and you could say my rect1 area equals, okay, and then you've got to call that function. How do I call it? Well, it's my rect1, and I'll get smaller here to make sure that I'm out of your way. My rect1 dot area, and then you've got to do the open close. Okay, why do I have to do an open close here? Because you are calling this area method. All right, you're not just printing out, dumbly printing a variable self.color. Now, if I had said self.area is length times width here, then I could just do my rect.area. But I'm not doing that. There is a method called area, and I am calling my rect1.area, and therefore, since I am calling that method, I have to put the open and close parentheses. I'm not passing it any parameters. Why? Because rectangle is going to tell it who it is, my rect1, and then it already knows the length and width. It calculates the area, and then it returns the area like that. Okay, so let's try this. And boom, do you see that? My rect1 length is 2, and my rect1 area is 2, because 2 times 1, so it returned the area. Yeah, all right. Or what you could do is you could come over here and you could do something like you could call, and you could just say area is equal to myrect1 dot area, and then the open close because we're calling that method, and then here we could just print area, and then let's try that. Boom, that works just as well. Myrect1 area is equal to 2. Is this kind of making sense? I think it's kind of making sense. Okay, and notice again that we are creating myrect1 here and myrect2 here, and then once those objects are created, I can play around with rect1 or I can play around with rect2, and I can go rect1, rect2, go back and forth. But Python keeps track that in this class there are 2 objects. There is myrect1 and myrect2, and it keeps them all separate because anytime we call it, it passes itself its name, so then it knows which one you are monkeying with, which one you're monkeying with. Well, what are other things that you might want to do? You might want to say def perimeter of self, so you've got to pass it who you are dealing with, and that would be self.perimeter. And that is going to be equal to 2 times self.length plus 2 times self.width. Does that make sense? The perimeter is the length, width, length, width. So 2 times length, 2 times width. That is the perimeter. And then what do we want to do with that one? We want to return and then self.perimeter. Okay, what's another thing that we might want to do? Well, we've got the area, we've got the perimeter. How about that diagonal? Okay, that diagonal. So define diagonal. We got to pass it self. All right. And then what do we do? Self.diagonal. Now this is what you got to remember. If I have this side which is length and this side which is width, what is that? That is the old Pythagorean theorem, which is the square root of a squared plus b squared, or the square root of length squared plus width squared. And so what I would do here is I would say that self.diagonal is going to be equal to, and it's going to be self.width, and then I got to square it, so I go star star 2, and then plus self.length, and then I got to square it, star star 2, and then I got to take that whole thing, a squared plus b squared, I got to take the square root of it, right? Because c squared is a squared plus b squared. C is the square root of a squared plus b squared. So I've got to take this whole thing outside the parentheses, and I've got to raise it to the 1 divided by 2, right? Because raising something to the power of 1/2 is taking its square root. Hopefully you know that. If you didn't, you just learned something. All right, now what we need to do is we need to then return. And I don't like using the same thing, so I'm just going to call it the diag, self.diag. I'm going to return that. Okay. And then I'm going to say here, return self.diag, because I want you to see that this diag is just what I'm naming the variable. This diagonal is the name of the method, so I'm going to return now self.diag, which I just calculated there. All right, so what I am going to do is I am going to create a rectangle that is 1 and 2, and then I am going to do all this stuff, and then I'll just come down here just showing that I can just come in. And now what I want to do is I want to know my rect1 diagonal is equal to space, and then that is going to be what? My rect1 my rect1 dot what? Dot diagonal. And then because I'm calling the method, I've got to put the open close. Now guys, one thing you've got to see here is you can't just call myrect1.diagonal if you haven't created a myrect1 object. Up here I create the myrect1 object. Right here I create the myrect1 object, And then because I created the object, then I can call my rect1 methods. But I couldn't just come in here and not create my rect3 and just come down here and say, okay, my rect3.area. It's going to crash because why? Because it hasn't created the object. It wouldn't even know what its dimensions were or anything, so the whole thing would just crash. Okay? So let's see what happens here. And so if we do this, boom, it says that my rect2 length is 4, and then my rect1 diagonal is 2.23. Now remember, we were 2 and 1, so that would be 1 squared is 1, 2 squared is 4. So this would be 4 plus 1 is 5. Square root of 5 is 2.23. Okay. You see, guys, this makes a lot of sense, doesn't it? It makes a lot of sense. Now, I'm kind of going to create sort of an artificial thing here for you, just so that you can kind of see how this works. What if I wanted to know the volume of the rectangle? Well, you say a rectangle doesn't have a volume, and you would be very right there, but what if I define volume, okay, and that is going to get self, and then the thing is, what would volume be? It would be self.volume would be equal to self.length times self.width times self.height. Okay, now this was a rectangle. We never talked about it being a box, but then let's just imagine, well, like I've got all these different room dimensions. I wonder what, it's like 40 by 15 is the dimension of the room. I wonder what the volume of that room is. Well, I could just pass it the ceiling height, and then it could tell me the volume of the room. But that was not part of this definition up here. But that's okay, because what parameter am I missing? I'm missing height. And the only thing that needs to know height is this volume. So what could I pass it? I could pass it h for height. All right. And here I could say self.height is equal to h. And so I'm passing in that height parameter here, and then I'm setting it, and then I am using it. So you see, you can pass in parameters directly into your methods that were not part of your initial setup, if that makes sense. And that is a very important and very powerful capability. And so let's try that now. Let's say I could say my volume is going to be equal to my rect1 dot volume, and then what do I need to pass it? I don't need to pass it self, because it knows that I'm dealing with my rect1 because I'm using my rect1 dot. The my rect1 comes up to here, and then it passes it down in these selves. And so right here it knows that it's my rect1, but what it needs is h. And so let me pass it 5. Okay, so 5. And so my rect1 is going to be 2 by 1 by 5. That means the volume should be 10. And so then I'm going to print my rect1 volume is, and then I'm going to print my volume, which I got here. Let's see if that works. Okay, volume is none. What is this nonsense? My rect1 volume of 5. What is this nonsense? I passed volume h, and then I said self.height is h. Self.volume. What did I not do here? What did I not do here? I calculated it, but I didn't do what? I didn't return self.vol, like that. Okay, now let's run it. I hope this works. That scared me. That one scared me. Okay, boom. Look at that. Who is your huckleberry? I'm your huckleberry. Look at that. My rect volume is 10 because I passed it a parameter it didn't have, which was 5. I passed it into that method, and then it gave me volume back. And so that is just pretty neat, isn't it? Okay, so you can see that you can pass a lot of parameters in here, all right? But what also you've got to see is once you're inside this class, all of these functions share with each other. Okay, so if you set self.color up here in this other method, you can use that self.color as long as it's in the same class. Now, if I got a different class, the methods in this class are not going to share with the methods in this class, but once I create a class, all the methods sort of share the data. And so like when I go to area, I don't have to pass area self.color, self.length, and self.width. I've just got to pass it self, and then I can use those because those are sort of sharing those variables between the different methods. But I want you to also see that, like if I say if I said something like x equals 7 here, then if I was just out here out of this class down here, I couldn't say print x. It's not going to know what it is because all of those variables are sort of wrapped up inside that class statement, and you access them by this, by calling like self.area, calling like rect1.area or rect1.perimeter or rect1.diagonal. And so let's just see if we can do one. So let's say that we have a I'm just going to play with one and make sure all those functions work, that I don't have a mistake in there. So I am going to say print color is, and then what would that be? That would be my rect1.color, and that is just the variable because I don't have to call anything because that is set here. It doesn't have to be called. The init is called automatically. Then I'm going to print and I'm going to print length is, and then that is going to be, and this should have been a comma. Okay, doesn't count as a mistake if you can't catch it before you read it. My rect1.length, like that. Okay, and then print width is, and then that would be my rect1.width, like that. Okay, my rect1.width. So my rect1.color, my rect1.width.length, my rect1.width, and now I'm going to say print area is, and that would be comma my rect1.area. What has to be different about this one? This one is calling the area method, so I have to put the open and close parentheses. And I really belabor this point because it's very easy to get those two mixed up, and you got to understand them and you got to do them right. Print, okay, print perimeter is, and then comma my rect1.perimeter. Did I call it that or something simpler? I just called it per. Okay, so then that would be per there. And that was a method, so I got to call it. I think that's right. Okay. And then print volume is, and I'm going to say that the room is going to be 10 foot tall, so it's going to be my rect1.volume, and I'll pass it a 10 foot high. And let's make sure I called that volume, so it needs to be VOLUME, right? Because I'm calling the method volume, so I've got to use method, and I've got to pass it that H, which is like that. Okay, and then I think that is everything. Let's run this baby. Boom! Look at that. Do you see that? Look at that. Okay, so The color is red, the length is 2, the width is 1, the area is 2, the perimeter is 6, and the volume is 20. Okay, because 2 times 1 times 10 would be 20. Okay, so that, man, that really looks like that is working. Okay, I don't like being this small. I feel insignificant. I feel like you're not paying attention to me when I make myself that small. Okay, so do you see how these things work? Now, what I could do is I could create a different rectangle, and I could say, now I've just created one, my rect 1. Now I'm going to create my rect 2, and my rect 2 is going to be equal to rectangle, and it is going to be equal to blue, and it is going to be 4 wide. Do I go 4 long and 3 wide? And now I'm going to print your diagonal is, let's see how smart you guys are. Can you tell me what the diagonal is going to be? Can you tell me what the diagonal is going to be? It would be my rect 2 dot diag, and I gotta see what I called it. I called it the full diagonal. The full diagonal. My rect 2 dot diagonal. And then because I'm calling the method, I've got to put the open and close. Okay, it is a 3 by 4. What is the diagonal? Boom. Your diagonal is 5. It's the old 3, 4, 5 triangle. Did you guys recognize that? You guys that are in high school might be taking the ACT. Always recognize that for a right triangle, if one side is 4 and the other side is 3, the hypotenuse is going to be 5. It is a 4, 3, 5. It is a 3, 4, 5 triangle. If the two legs with the right angle are a 3 and a 4, the hypotenuse is going to be a 5. And so that's one of those things that you should know. So I just threw that in. And then what I can do is I can still come back and say my rect, I can still come in and just say print first diagonal is, and then that would be what? My rect 1 dot diagonal. I'm just trying to show you that when I start playing with my rect 2, it doesn't forget my rect 1. It can still play with my rect 1. And so let's try that. And yeah, the first diagonal is still the square root of 5. Boom. Okay. This has been a lot of fun. I hope I just haven't beleaguered you with this by repeating myself, but it was just like, this was something I had so much trouble understanding. I really wanted to reinforce your learning and make it perfectly clear how these things go. Okay, now I'm going to give you a homework, and you really need to try to do this, okay? And so what you're going to do is you're going to create a class, and that class is called students. And so what you would do is you would create a student by, like, you know, giving him, like, you would create an object which is a student, and it would be like student 1. The next object would be student 2. The next object would be student 3. The next object would be student 4. Well, when you create that object, that student 1, what are some things that you're going to want to need to know? You're going to need to know his first name and his second name, or her first name and second name. So you're going to have a class called students. When you say students 1 is equal to student, what 2 things do you need to pass to that class? Well, like first name and last name. So you pass 2 things, first name and last name. Then you could come back and you could print out, you know, student 1 dot first name, and you could print out like student 1 dot last name. Or you could print out student 1 dot first name, student 1 dot last name. So that would be really, really clear. That would just be, that could all be done like in this init here. That would be really, really easy. And then what you would be passing here is self, like first name, last name. Okay. But then I want you to have a method, and what that method would do, that method would input grades. Okay. So you would say like student 1 dot input grades. Well, what would you have to do? You would have to pass it how many grades, and so you would have to have one of these where you pass an extra number. You have to pass like 5, and then this method would get the 5 grades of student 1, and then student 2 you could call the grades. So what the methods are, so you're going to create students, and the students you're going to, when you create, you're going to have a first name, second name, but then you're going to have a method that will input that student's grades, and then you're going to have a method that will print that student's grades, and then you'll have a method that will average that student's grades, and then you're going to have a method that will find that student's high grade, and then you're going to have a method that will find that student's low grade. So it was sort of like our old problem of inputting grades, averaging grades, finding the high grade, finding the low grade, but you were going to do it in a class. And then each student, you could just type in student 1 dot high grade, and then it would tell you what student 1's high grade is. Or you could put in student 4 dot average, and it would tell you what student 4's average is. Does that make sense? Okay, really try to do this, and I will come back next week in lesson 19. I will do it for you. But man, when I do it and you guys just follow along with me, it looks so easy, and it looks easy when you're watching me do it. And then because it looks easy when you're watching me, you understand what I'm doing, you think you understand it, but then you can't do anything on your own. So I need you to go out and try to do this grades assignment, this student class. I need you to try to do that on your own and do your absolute best, and then leave me a comment down below. I am legend if you get it, or I folded up like a cheap Walmart lawn chair. Okay, did you fold up like a cheap lawn chair, or are you legend? I really want you to be legend. Okay. And if you absolutely positively can't do it, then do it with me next week. But you need to spend at least an hour trying to do it on your own. And then you'll get hung, and you'll just know I just don't know how to do this. And then when you see me do it, then, okay, yes, I understand it. Then you'll really understand it because you see how to do it after you were completely lost. But you need to get to that completely lost point for the learning to occur. Okay, guys, I really hope you're having as much fun taking these classes as I am making them. If you like the video, be sure to give us a thumbs up. If you have not subscribed to the channel already, click that subscribe button and then ring that bell so you will get notifications when my future lessons come out. And then if you haven't already, be sharing this channel with other people on your social media. We need more people that are doing useful things like coding and less people spending their time watching silly cat videos. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.